Hello everybody, I'm Nick, and after years of waiting for discriminated unions in C#, .NET 11 Preview 3, which I have installed right now and I can actually run union code, we finally have unions merged in. The only thing you need to do for this to work is install .NET 11 Preview 3, which is not officially out yet, but if you try, you can install it, and then enable the preview language version, and this will give you access to unions. Now, if I open any of this code, you're gonna see a bunch of compilation errors. That is just front-end errors. This means that if I go here and I say build the solution, it will still work successfully because it's actually the .NET 11 compiler that does the compilation, not the front end of Rider. Or if I use Visual Studio Code over here and I open any of these, you're gonna see similar warnings and errors. Don't worry, this is how the feature is actually working, and eventually when Visual Studio Preview comes out, it will have support for this and eventually Rider. So let's just talk about unions. I have talked about discriminated unions and unions for years now, but we only now have the way to actually run them. And very quickly, I'm going to show you the most basic surface level example of how this is supposed to work and what they're supposed to be doing. I have made a video explaining the different types of unions, so union types, things like how structs and classes will be affected with the union attribute, the interfaces involved and all that. Here I'm going to show you the latest up-to-date version of this feature, and Microsoft is watching this video, so if you have feedback on what they're doing, please leave a comment down below. I have my own thoughts on this, and I will give you my opinion on this video. And it is of my opinion that this is almost as good as a 30% discount we have now on Dome Train, hands-on 30 at checkout. You can get any of our courses or the subscription for 30% off, from MCP courses to AI agents to solid principles, hands-on courses, learn hands-on C#. This is completely free, as well as the SQLite, data structure and algorithm, learn Go, Python, TypeScript, Bicep. Check the link in the description and get any course you want for 30% off. But let's take a look at the absolute simplest example, and let's take a look at the old way of doing, let's say, a result type. So if you want to have a result that can be a success or an error, you would have, in a sort of very efficient way of writing it and a very, very basic way of writing, something like this. You will have maybe an abstract record of the result type and then a t-type parameter, which can have a value or an error message. All the simplifying here, but you would see this a lot, and people have used things like one of in the past to have one of certain types as a result, and they would use it in APIs, middleware, and so on. Or you'd use something like language extensions, which gives things like result types and all that with all the semantics. These are all overcomplicated, and this will significantly simplify it. But as a very basic idea, what you would have is something like this, where you have some random chance, because I don't want the compiler to complain, to have something be either a success with a random number, or let's say a failure that the user already exists, and then you maybe switch on it to return something. However, if I was to go ahead here and just comment this out, let's say in this switch, and then I go old result demo and I just say run this. So if I was to run this code, what you would see is that, yeah, in this case it would work. In the other case, if I run it enough times, I'm going to get an exception because it says non-exhaustive switch expressions file too much input. However, this would only happen in runtime. And by the way, as of recording this right now, this would still only happen on runtime for union types because the compiler is not there yet. But the promise is that we can do all this with way less code, have the option to be very efficient as well, but also have an opinionated default state and not lose any of the functionality. How? Well, let's say I have the same success and error types over here, and this might actually clash with other types I have created, so we'll go then later to that example. But let's just say we have these two records. One represents success of some type, the other one represents failure. If I wanted to have a type that can be either a success or an error, but only have one state at a time, similar to F# unions or maybe Rust enums, well, now all I need to do, and I can actually just say, just for the compiler to not complain here, new success and new error, I can simply say union, so this is a new keyword we have now, of type new result, and that would be of type T over here, and then this can either be a success of T or a new success of T or a new error. This is valid C#. at least in the preview version of the next C# version. So if I was to define the result type that can be, or a new result type that can be either the success of the random number or the user already exists. So if I just update this over here just so it's happy, this code compiles and runs. Obviously, it doesn't do anything because I'm not really printing anything, but I could switch on it or check on it to say if this is of type new success or new error, then take that message, translate it into something, use its value property from here or the message from here, and then almost half the time you will get the number, half the time you will get the user doesn't exist. And you have check exhaustiveness. So because this can be one of the two types and only one of the two types, because these things are closed and can be extended, then if I run this, I'm gonna get a runtime exception in this case, but I think this will be actually a compilation level exception, so you won't be able to build your project in this case, but I wasn't able to recreate it with the current version of the compiler. Then you're gonna get a warning saying, hey, you have to handle this, otherwise I can't move forward. So basically, this replaces what we saw before in that other old result demo. Now, this is sort of the default opinionated way of doing a union. There's more ways to do this. Let's take a look at a few examples. First, I'm gonna go back to the basic demo, and similar to these types, what you have here is a record of a cat, a dog, a fish. This doesn't just work with records, but I'm just showing you using records. So you can make a public union of something that is a cat, a dog, and a fish. You don't need to define a name here. This is just a union, a collection of things that this can be. And then something like this will allow you to define a cat of type pet, dog of type pet, and fish of type pet. This sort of looks like inheritance, but it's not, kind of. If I actually build over here and then I go, well, let's just put something so this doesn't complain. Right line, yeah, you're fine. Then if I am to build the solution and I go into the lowered code, then you'll see over here that this union keyword actually translates into a struct by default. We'll see later how this can be different with the union attribute and then implementing the iUnion interface, which, by the way, you can also do manually to take control over performance. But as you can see, this is all backed by a backend field that is an object, which can be problematic because that means we will box. So if these are structs and not classes like they are here, then they will be boxed. There's ways to go around it. We're going to see it in a second. But this is nothing but a special type of class which has a specific attribute or a bunch of attributes in this case, and the iUnion interface to then allow the compiler to limit it into specific situations. The rest, the records over here, they're just classes by default, so nothing really changes. These are normal types. So what I have here is the 3 pets. I just defined them. They're all pets. And then if I switch on them, I can get the description of the pets. So if I say basic demo and then I run it, then you're gonna see all the 3 different types of pets. Again, if I missed one, so if the fish wasn't handled, even though it is part of one of the things that the pet can be, then you're gonna get an exception. Not runtime. Hopefully when this releases, that's what I understand, it will be a compilation error, so you won't be able to compile unless you handle everything, which is what you want and why this feature is so important. Switches in C# don't have that restriction. You could have sort of a switch that doesn't handle everything that it can be, so here we're fixing that. You will also be able to have ad hoc unions. So I've created a few helpers here to allow for this feature to work because of how the runtime is shipped. Don't worry about it. The main thing you need to take a look at is that you don't actually need to define a named union for everything. You can have a union type that can be either an integer or a string and then handle that appropriately. So here I have a read setting that can be a decimal, a string, or a boolean, and then I'm handling all of those types appropriately by passing the type. So if it's an integer, we do this. If it's a string, we do this. Pattern matching. Now, one of the biggest complaints of how unions work in this default opinionated way is that this will box. So Microsoft actually gives you a non-boxing alternative. So the non-boxing way is not as elegant in the way it looks, but you can have a union attribute on a struct and then implement the IUnion interface. And if you have something like this, and now we're playing with structs, then you can have these try-get-value methods, which will prevent the boxing that will happen with the value property that uses object that is nullable. So this is the boxing version, this is the non-boxing version. And from what we understand, this is the main issue of the IUnion interface. So if you need control over that and you want to have this non-boxing alternative, then you would use the try-get-value, and then you'd get an out parameter of that struct, which depending on how you implement wouldn't allocate. There's also something called the union member provider, which I couldn't find a way to actually use in this specific version, but the idea would be that you can have a nested interface of IUnion member provider. You can see over here how this would work with the result type, where you have this nested interface and then these create methods acting basically as a factory. And then if I search a bit lower, you can say result of type string union members create hello. Doesn't look as elegant, but again, more flexibility on what you can do. Then you have union nullability, which is also something they've taken into account. The compiler tracks the null state of the value separately, and a union containing null are distinct concepts, and pattern matching handles both. So here you have a school member, either a student or a teacher, and then you have a nullable school member. So if I use the find member method over here, then you have the student being matched, the teacher being matched, and then the value itself being null, which is also being matched with this default parameter. You see a lot of switching here because it's actually a lot of what you will be doing. This is building on pattern matching, and it actually plays really, really nicely with pattern matching. Here, because school member is not nullable, there is no compilation error saying that you need to handle null. However, here, you would need to handle null if you have a member that is nullable. A lot of stuff to take in. This is pretty surface level because I don't have the compilation support and some of the types are missing, so I had to add them myself in the right locations for this to even work. But it does work, and it looks pretty promising. Now, it seems a bit different than we originally expected, but we finally have it in preview, meaning it is pretty unlikely it's not gonna come out. We have seen similar cases with the field keyword being pushed a bit further out, even if it's in preview. However, I really hope this comes out and we have a chance to use it. But now I want to know from you, what do you think about this feature and what's the use case we really hope to use this when it's out? Leave a comment down below, let me know. Well, that's all I had for you for this video. Thank you very much for watching, and as always, keep coding.